welcome to online classes. As we are already aware, the importance of quantitative aptitude in different competitive examinations, whether it is banking examination or SSC examination or UPSC examination or even TSPSC examination, any kind of competitive examination, the subject quantitative aptitude is playing a vital role, that everybody know. To get any kind of government job, so this is the main key role, quantitative aptitude. If you have a good command on this quantitative aptitude, then you can able to crack any kind of job. So that is why keep in mind this concept. So because of this reason, give more importance to this quantitative aptitude. Okay, in this session, in quantitative aptitude, I come up with one more topic. Topic name is trains. The topic trains is actually the part in time and distance only. If you have a good command on time and distance, then you need not to worry about trains, because the concept, all the concepts what we discussed in time and distance is also useful in trains. So what we know usually, so in basic concepts in time and distance is speed formula. Speed formula is what? Speed is equals to distance by time, that everybody know, right? Speed is equals to distance by time. For example, so let us say if you observe here I am taking some basic formulas. Speed is equals to distance by time. This is one small formula, everybody know. So from this main formula we come up with two formulas, that is next formula is, for example, I have to find out the distance. So here distance is equal to what we can write here, speed into time we can write. This is second important formula. And third important formula is again from this. For example, if we have to find out the time, time is equals to what we can write here, distance by speed we can write. Time is equals to distance by speed we can write. So remember this formula, speed is equal to distance by time. And remember one more thing, knowing formula is not necessary, but application part, application, how we are going to use that part. Let us say for example, he given distance and time, then we have to find out the speed, or speed given, time given, we have to find out the distance, or speed given, distance given, we have to find out the let us say time to reach certain distance in a specified given what you can say with a specified uniform speed. Okay. So because of this reason, and this is one concept, knowing formula is one concept. And secondly, if you focus on this, secondly if you focus on what you can say some kind of definitions what we already discussed in time and distance. Let us say here first concept is units also very important, units also very important. So here units means what? Converting, whether speed, the notation for speeds is either we can write kilometer per hour or meter per second. What does it mean? So for example, if distance is there in terms of kilometers, then the time must be in hours. So in this case, the distance, the what you can say, the units for speed is equal to, we can write kilometer per hour or kmph. For example, distance is in meters, then time must be in seconds. Then in this case, the formula for speed is equal to, we can write either meter per second or simply mph we can write, either meter per second or simply mph we can write. So this is the importance of units. For example, if units are not there like this, what does it mean? So it is not there from sometimes we need to find out the, we need to what you can say, convert the units from kilometer per hour to meter per second, or meter per second to kilometer per hour. So this conversion part also very important. Now we will see how to convert the units from kilometer per hour into meter per second and meter per second into kilometer per hour. Let us say see here we will see the one small formula. So formula is as follows. For example, x kilometer per hour is there. This x kilometer per hour I have to convert into meter per second. what I have to do? X into, I have to multiply with 5 by 18. Then this will be, what will happen? Meter per second. Similarly, for example, x meter per second given. This x meter per second I have to convert into kilometer per hour. What you will do? X into 18 by 5. So here the units are kilometer per hour. So x kilometer per hour can be written as x into 5 by 18 meter per second, and x meter per second will be written as x into 18 by 5 kilometer per hour. So like this we can convert the given units from kilometer per hour into meter per second to kilometer per hour. So here remember to convert the big units into small units, small value by big value. Here the two numbers 5 by 18 and 18 by 5. What does it mean? Kilometer per hour into meter per second, small value by big value, and a meter per second into kilometer per hour. Converting small units from big units, converting small units from big units. So what will get here? Big value by small value. This is one important concept, remember, in this aspect. Okay. So now we focus on one more definition before going to start the problems of trains. The next concept is here one more two definitions, important definitions. So one definition is average speed and second definition is relative speed. So average speed and relative speed we also discussed in time and distance. If you have an idea, then we look once again. So here first definition is average speed. Remember, average speed is not the averages of the given speed. One important word, average speed is not the average of the given speed. Okay. So simply average speed is equal to total distance traveled by, we can write simply total time. So by using this formula we can simply find out the average speed. Average speed is equals to what we can write here? Total distance traveled by total time taken to cover that distance. So from this average speed definition we have some more two important points. That is, for example, a person travelled from A to B. For example, a person travelled from A to B with x kilometer per hour and B to A with y kilometer per hour. What does it mean? Here distance is same. If a person is covered two equal distances with either equal or unequal speeds. I repeat, if a person covered two equal distances with equal or unequal speeds, then in that case the average speed for the whole journey is what will write usually? So 2 by 1 by x plus 1 by y we will write. So 2 by 1 by x plus 1 by y, that is equal to what we will write here? 2xy by x plus y, 2xy by x plus y. This is one formula. And secondly, for example, let us say three equal distances, let us say A to B, B to C and C to D. So A to B with x kilometer per hour, B to C with y kilometer per hour and C to D with z kilometer per hour. For example, if a person covered three equal distances, then average speed for the whole journey is what will write? It must be in harmonic progression. That's why we will write 3 by 1 by x plus 1 by y plus, right, 1 by z. If you simplify this, simply we can write as 3xyz by xy, right, 3xyz by xy plus yz plus zx. This is one important formula. Okay. So if two equal distances, 2xyz by 2xy by x plus y, three equal distances, 3xyz by xy plus yz plus zx. This is one formula. And secondly, in general, average speed is equals to what you can write? Total distance travelled by total time taken to cover the distance. So this is one important aspect. And one more thing I need to stress here, that is regarding relative speed. Here the word relative is indicating comparison. Relative speed means what? I have to compare the speeds of two trains, because our topic name is trains. Okay. For example, if two trains are moving in same direction, so let us say the speed of the one train is equal to x kilometer per hour and speed of the another train is equal to y kilometer per hour. I repeat, speed of the one train is x kilometer per hour and speed of another train is y kilometer per hour. For example, if both the trains are moving in same direction, then average speed, in this case average speed is equal, sorry, I am very sorry here, it is not average speed. So, it is about a relative speed, it is not average speed. So, relative speed is equals to simply what you write here, x minus y km/h. One important aspect. For example, if they are moving in opposite direction, then relative speed is equals to what you can write here, x plus y km/h. For example, if two objects are moving in same direction, then relative speed is equal to difference of their speeds. If they are moving in same, so I repeat once again, if two objects are moving in same direction, then relative speed is x minus y. If two objects are moving in different, that is opposite direction, then relative speed is equal to x plus y km/h. So, these are the one or two more interesting concepts. Remember, it is about only speeds, it is not about distances. We come up with the distances later. So, average relative speed same direction minus relative speed opposite direction, we can take it as plus. Okay. Remember these 2 points. Now we will see the two important points regarding what you can say, trains. Then we will start doing some kind of model bits. Okay. So, now we will see one more concept. The concept is, for example, one train length is equal to, let us say, for example, x meters. One train length is equal to, for example, x meters. The x meters length of the train, has to cross a stationary object. So, this stationary object, it might be either a tree we can take, or it might be what I can say, an electric pole we can take, and or the stationary object might be any person standing beside the track. Okay. For example, train length is equal to x meters. So, x meters length of the train has to cover a stationary point. Let us say, for example, x meters length of the train has to cover a tree or a person or a pole. Then the train has to cover how much meters here? So, simply here we can take it as x meters. Here the distance is equal to what you can take here, x meters. So, x meters length of the train has to cover or else has to cross a tree or a electric pole or a man standing beside the track. Then train has to cover how many meters? X meters. Indirectly, this is nothing but length of the train. Okay. This is one case. And secondly, for example, let us say train length is equal to x meters. One more important concept here, train length is equal to x meters. And let us say, for example, I am taking a platform length, we can take it as a platform length is equal to, let us say, y meters. So, platform length is equal to y meters. So, it need not be platform, it might be a platform, or it might be a bridge, okay, or it might be tunnel, okay, whatever platform or bridge or tunnel. So, length is equal to how much we can take here, y meters. So, x meters length of the train has to cross completely a y meters length of a platform or a bridge or tunnel, something like that. Then the train has to cover total how much distance we can say. So, length of the train plus length of that object. So, length of the train equal to how much here, x meters, length of the object equal to how much here, y meters. Okay. So, these are the two important aspects. Remember these 2 points once again, train length is equal to x meters length of the train has to cross a person or a tree or electric pole, something like that. Then train has to cover x meters distance. And secondly, x meters length of the train has to cross completely a y meters length of a platform or a bridge or tunnel, something like that. Then train has to cover total distance equal to length of the train plus length of that object. So, train length is equal to, let us say, x, and the object length equals to y. So, simply we can take it as x plus y. Okay. So, by keeping these concepts in mind, now we will see some of the different models from trains. Okay. Before going to start some models, now we will focus on two basic definitions of what you can say, trains, two basic definitions of trains we can say. Okay. So, here this point we already discussed, when a train is passes a stationary point like tree, man, electric pole, the distance covered is length of the train. And second point is, if the train is crossing a platform or bridge or tunnel, the distance covered by the train in crossing is equal to the length of the train plus length of that platform or bridge or tunnel, etc. Okay, this point also we covered, and we have seen average speed, relative speed, and conversion of units also. Conversion of units means what? Converting kilometer per hour into meter per second, converting kilometer per hour into meter per second, and meter per second into what? Kilometer per hour. That we can done by multiplying with either 5 by 18 or 18 by 5. Okay, let's start by taking one small example. So here is the first question. So question is what? Convert 72 kilometer per hour into meter per second. Basic question. Okay, convert 72 kilometer per hour into what? Meter per second. See, observe here what he given, 72 kilometer per hour. So this I have to multiply with converting kilometer per hour into meter per second. What I have to do? Multiplying with simply 5 by 18. Simply 5 by 18. So what will get here? 18 1s, 18 4s. So 4 5s, how much I am getting? 20 meter per second. Means per second 20 means 20 meters distance is equal to what you can say, per hour 72 kilometers distance. This is one basic example. And secondly, convert 30 meter per second into kilometer per hour. Convert 30 meter per second into kilometer per hour. So here he given 30. Okay, so now we have to convert this meter per second into what here? Kilometer per hour. And converting small unit into what? Converting small unit into big unit. That's why big value by small value. 5 1s, 5 6s. That is equal to what we can write here? 108 kilometer per hour. Either we can write kmph or kilometer per hour. So in this way we can convert the meter per second into kilometer per hour or kilometer per hour into meter per second. These basic examples I don't want to stress on this more, anyhow I think you are already aware. Okay, so now we focus on third question onwards. So this third question onwards, from question number 3 onwards, right? From question number 3 onwards, so it is about what we can say, train time and trains problems we are going to we cover. So let's say question number 3. See, observe your third question. So third question, what he given? 400 meters, right? So we'll erase this. Now see, focus on that. 400 meters length of the train crossed a tree in 25 seconds. Find the speed of the train in meter per second. I repeat, here train length equal to how much given? 400, right? Train length is equals to how much given? 400 meters. What this train has to do? This train has to cross a what? Train has to cross a tree in how many seconds? 25 seconds. Distance is in terms of what? Meters. So since distance is in meters, time must be in what? Seconds. We need not to convert the what you can say units. So now we can find out the speed. Speed formula is what? Speed is equals to, we can write distance by time. Speed is equal to distance by time. So here remember, train have 400 meters length of the train has to cross a tree. So since train has to cross a stationary object, that is tree. So to cross a tree, train has to cover completely how many meters? 400 meters. That is equal to length of the train. So speed is equal to distance by time. Distance is equal to 400 and time is equal to how much here? 25 seconds. So meters is there, seconds is there. That's why what you can say, units per speed is meter per second. So now this will simplify. 25 1s, 25 1s, 25. Still 15 left here. That's why 25 6s, 150. So hence what is our final answer? The speed of the train is equal to 16 meter per second. I hope you understood. Okay, simple concept here. Train length equal to how much? 400 meters. And train what it has to do? It has to cross a tree. So to cross a tree, train has to cover only its length. So that's why train length equal to 400 meters and time is equal to 25 seconds. So hence answer is 400 by 25. What is the speed here? 16 meter per second. Sometimes he asks you to convert into kilometer per hour. What you will do? We will simply multiply with 18 by 5. You will get the answer. Okay. I hope you understood this question. Now we will take one more example from trains. So now we focus on example number 4. Observe here, fourth example. See, fourth example is as follows. Now we will erase this part. See, train length equal to how much given? Train length is equals to 400 meters, right? Train length is equals to 400, train length equal to 600 meters length of the train crossed 800 meters length of the platform in how many minutes? 3 minutes. Find the speed of the train in kmph. See, specifically he mentioned we have to find out the length of the train in what? Kilometer per hour. But train has to do what the train has to do here? Train length equal to 600 meters and platform length is equals to 800 meters. 600 meters length of the train crossed 800 meters length of the platform in 3 minutes. So time also given. Time how much is given? 3 minutes. One important beautiful concept here, that is distance is there in terms of meters. Since distance is there in terms of meters, then time must be in seconds. We have seen earlier, but he given time in terms of minutes. That time we have to convert minutes into seconds. We know 1 minute is equals to 60 seconds. That's why 3 minutes is equal to 180 seconds. Chalo. So now we will do, he asked you to find out the speed. Anyhow, speed formula there is no change. Speed is equal to what you can write? Distance by time. So distance means, see here, train has to cross a platform. Since train has to cross a platform, so what you can write here? Train has to cover 600 meters length and 800 meters platform length. So by how many minutes here? 3 minutes. So you should not write actual like this, because here numerator part is in terms of meters, whereas denominator part is in terms of minutes. That's why this also will convert by multiplying with 60. So what I am getting? 1400. 1400 by, either you can keep it as 3 into 60 or you can add 180, however no issue. So 0 0 cancelled. Okay. Then we can cancel with the second table. 2 3s are 2 70s are, right? 70 by 9 I am getting. 70 by 9. And one more important concept here, there is one small correction. This is okay, this is right only, but what he asked you to find? He asked you to find out the speed in terms of kilometer per hour, not meter per second. That's why this 1400 writing as it is into 3 into 60, no issue. This is in terms of meter per second, but you have to convert to kilometer per hour. That's why 18 by 5. Now it's fine. So 0 0 cancelled. Then we can cancel. See, 6 3s are 18. For this 18, this 18 also cancelled. Then 5 1s are 5 2s are 10. 5 8s are 40. So hence, what is our final answer? 28 kilometer per hour. Either you can write kmph or kilometer per hour. So 28 is the final answer. 28 is the final answer. See here, of course you may solve this question already, but the concept is train has to cross a platform. That's why train length plus platform length and conversion of units. Distance is in terms of meters, time must be in terms of seconds, but he given in terms of what you can say minutes. That's why we converted, and hence answer for this fourth question is 28 kilometers. So now we focus on next question, that is question number 5. So to discuss, there are 2 questions are available in this slide. See, aspirants are see, you might have seen there are 2 different questions. Okay. First question is what? A train crossed the person with 60 km per hour in 45 seconds. he asked you to find out the length of the train. I repeat this question once again. A train crossed the person. Train crossed the person means, so train has to cover its length. Train has to cross its length. A train crossed the person with 60 km/h in 45 seconds. See, we will take what he given. See here what he given, train length given, train length we have to find out, speed given, time given, right? Speed also given, time also given. So speed given and time given. So speed equal to how much given, 60 km/h. Speed is equal to 60 km/h, 60 km/h, and time is equal to how much given, 45 seconds given. Now interestingly observe here, and he asked you to find out the length of the train, right? What he asked you to find? Find the length of the train. He asked you to find the length of the train. So length of the train means what? Indirectly, for example, that length of train is equal to consider as distance, right? So distance we have to find. Here we have to find out the distance. Distance formula is what? Speed into time. That everybody knows. Distance is equal to speed into time. Speed how much given? 60, and time how much given? 45. But one small thing here, what it is? So speed is in the speed, time is in terms of hours. What does it mean? Speed is equal to 60 km/h. Per hour means time is in terms of hours, whereas here time is in terms of seconds. Is it there in same units? No. That's why what you have to do? We have to convert. Converting this km/h into meter per second. Converting km/h into meter per second. Multiplying with 5/18. So if you simplify this, you will get the answer for that. See, observe here, we can take it as 9 table. 9 2s are 18, 9 5s are 45, 2 1s are 2 30s. Hence, what is my final answer? 30 into 5, 150. So 150, is it kilometers or meters? So simply 150, it is meters. Why it is in meters? Because I am converting speed from km/h into meter per second. Converting meter per second. So time in terms of second, distance in terms of meters. That is why the answer for this question is equal to what you can say, 150 meters. I hope you understood this question. Okay. So now we focus on question number 6. Question number 6. See, observe what he given. Train length is equal to 500 meters. Train length is equal to 500 meters. 500 meters length of the train moving with 60 km/h speed. How much time required to cross a tree? How much time required to cross a tree? What train has to do? Train has to cross only tree. Train has to cross a tree. To cross a tree, train has to cross a tree. So train has to cover how many meters here? 500 meters distance. Okay. That's why. See, in previous question, he asked you to find out the distance. Speed given, time given, he asked you to find distance. But whereas in this question, distance given, speed given, he asked you to find out the time. Okay. I hope aspirants are having you are focusing on this concept. Okay. Let us start doing solution. Now see, observe here, 500 meters. Train, now we will take the length. Train length is equal to, train length means indirectly distance, right? Distance equal to how much given? 500 meters. Speed also given. We know already, speed equal to how much given? 60 km/h. Speed is equal to 60 km/h. 60 km/h. He asked you to find out the time. Time formula is what? Time is equals to distance by speed, right? Excuse me. Time is equals to distance by speed. So distance already there. Distance is how many meters are there? 500 meters. So speed. Speed how much there? 60. If you calculate blindly, you will get the wrong answer. Why? Because so here distance if you focus on distance, distance is in terms of meters, but whereas in speed the distance is in terms of kilometer per hour. Kilometer per hour means distance in kilometers, time is in hours. So here meters, here kilometers. Is it same? No. We have to convert the units from kilometer per hour into meter per second. So that's why multiplying with 5/18. Okay, simplification. So it's a small simplification. There is no issue with this. So here 5 0 0 cancelled, 5 tens are 50 I am getting, 6 ones are 6 threes are. So 10 into 3, 10 into 3 means how much I am getting? 30. 30 hours or 30 minutes or 30 seconds. That means here clearly the answer is 30 seconds. Why the answer is 30 seconds? Because converting kilometer per hour, converting kilometer per hour into what? Meter per second. Converting kilometer per hour into meter per second. That is why answer what I am getting? 30 seconds. So this is also one beautiful important concept. Now we focus on next question. Okay, that is sixth question we finished. Now we focus on question number 7. Now we focus on question number 7. See, observe here, 7th question. What he given? 7th question here is follows. A train 110 meters long passes a telegraph pole in 3 seconds. How long will it take to cross a railway platform 165 meter long? Beautiful question. So here a train length also given. Train length equal to how much is given? 110 meters. Or train 110 meters long passes a telegraph pole. Indirectly train has to cross a pole. So since train has to cross a pole, train has to cover distance which is equal to its length. In how many seconds? 3 seconds. Here you need not to convert the units because distance is in terms of meters, time is in terms of seconds. Okay. How long will it take to cross a railway platform? How long will it take to cross a railway platform 165 meter long? Here interestingly we have to find out the time. So okay, to find out the time, first of all we have to find out the speed of that particular train. There are two different cases. Case 1, okay, first case we will focus on this. So case 1 is what? 110 meters long train. Train length is equals to 110 meters. How many seconds? 3 seconds. Speed is equal to distance by time. If you simplify this, 3 3s are 9. Okay, 3 or else do one thing, since it is not exactly going, don't change of this. Simply speed is equal to what you can write? 110 by 3 seconds. Don't change that because you are getting what I can say, mixture fraction. Don't change that. So this is simply what? Speed of the train. The same train, what has to do? It has to cross a railway platform of length how much? 165 meter long. How long? How long means here we have to find out the time. Time is equal to, again we can write distance by speed. Time is equal to distance by speed. So here distance is equal to what you can write here? Length of the train plus length of the platform. Length of the train plus length of the platform by, so here there is no change here, 110 by 3. 110 by 3. So if I will simplify this, what I am getting here? 275, right? 275 by 110 into 3. Simplification with 11 table, 11 tens are 110, 11 twos are 22, 11 fives are 25. Again with 5 table, 5 twos are 10, okay, or simply you can do it in 2 ways. 25 threes are 75, 75 by 10 means 7.5 seconds. One possible answer is 7.5 seconds. So if that is not there, 75 by 2. 75 by 2 means, or sorry, it's not 75 by 2, still I have to simplify. 5 twos are 10, 5 fives are 25. What I am getting? 15 by 2. So 15 by 2 is again equal to 7.5 or 7/1/2, 7.5 or 7/1/2. There are two cases. By using this first concept, we can able to find out the speed of the train, and the same train has to cross a platform of length what, 165. So using the speed in second case. This is second case. I hope candidates are getting an idea. Okay. This is also one beautiful concept in time. There are 7 model. See, each and every question is one different model. We have seen 7 different questions as of now. Remember, whatever the model, what the train has to do, train has to cross a person or a tree or a pole, or train has to cross a bridge or tunnel, or what you can say simply platform. If it is in case of a bridge, tunnel or platform, train length plus that particular object length. So train has to cross a person or a what you can say stationary object, simply train has to cross x meters if train length is x meters. I hope you understood this model also. So now we focus on question number 8. Okay. Now we are going to discuss 8th question. Okay. See, observe here everybody. Now I am erasing all this. 8th question. Question number 8. What he given? A train 100-meter long running at 36 km/h can cross a bridge 150-meter long in. So indirectly here we have to find out the time. Observe everybody. A train 100-meter long. So indirectly he given length of the train. Train length equal to how much he given? 100 meters long. At the speed also given. Speed how much he given? 36 km/h. Can cross a bridge. See, just now I told train, what the train has to do? Train has to cross a bridge. Bridge length is how much? 150 meters. Since train has to cross a bridge of 150 meters length, then train has to cover or train has to cross train length plus that bridge length. So here total distance equal to what we can take here? 100 meters plus 150 meters. So total train has to cover how much here? 250 meters, and speed also given. Speed equal to how much given? 36 km/h given. He asked to find out the time. Time formula is what? Time is equal to distance by speed, right? Time is equals to distance by speed. This is the concept what he given. See, observe all the values he given. Distance is equal to given 250 meters and speed given 36. If you find blindly, then if you find you will get wrong answer, because here distance is in terms of meters, but whereas speed in terms of km/h. So km/h must be in terms of meter per second. That is why converting km/h into meter per second, that is equal to, after simplification, what I am getting? 25, because 8 in 1s are 8 in 2s are 36, 2 into 5 10. So 0 0 cancelled, what I am getting? 25 seconds. Is it seconds or minutes or hours? Clearly it is 25 seconds. Why it is 25 seconds? Because converting speed km/h into meter per second. Km/h into meter per second. Okay. Focus on this question. Now let us move to next question. Now we will focus on next question. Now question number 9. Now we focus on question number 9. Whatever the question, so simply observe what he given and what he asked to find. Now we come up with one more question, question number 8. So observe here, question is what? In how many seconds? In how many seconds will a train 105 meter long, 105 meter long, so train length given, running at 51 km/h crosses a man walking at 3 km/h in opposite direction? very beautiful concept. I repeat, in how many seconds? Blindly I have to find out the time. Okay. In how many seconds means blindly I have to find out the time. Time formula is what? Time is equal to distance by second, speed, sorry. Time is equal to distance by speed, that we know. Now what the train has to do? Train length is 105 meters. This 105 meters length of a train running with speed what? 51 km/h. This train has to cross a man. Very interesting word. Train has to cross a man. Since train has to cross a man, then train has to cover its length. So its length is how much? 105 meters. Now we will take the parameters what is given. So train has to cover 105 meters. So okay, and walking at a speed. What is the speed of the man? 3 km/h. How he is moving? Opposite direction. Okay, there is no issue with the distance. Distance equal to clear, that is 105 meters. But the issue is with now speed. Speed means whether do we need to take a train speed or do we need to take a what I can say, do we need to take a speed of the man? Means here we should take their relative speed. I told you earlier the definition of relative speed. How the relative speed will come? For example, if two objects are moving in same direction, if two objects are moving in same direction, then relative speed is equal to x minus phi. If they are moving in opposite direction, relative speed is x plus phi. So how they are moving here? They are moving in opposite direction. That is why simply we will take it as plus. So speed of the train is 51 and that is equal to 3. 51 plus 3, what I am getting? 54. This is the thing what he given. So now we will find out in the formula. Time is equal to distance, there is no issue, 105, and speed how much he given? 54. But if you take directly, again you will get the wrong answer, because distance is in meters, speed is in terms of km/h. This also we have to convert into meter per second by multiplying with 5 by 18. So 18 ones are 18 threes are 54. Here I am getting 3 into 5, 15. 15 ones are 15 sevens are 105. Since time is equals to how much I am getting? 7 seconds. This is also an important concept. Aspirants, I hope you understood about this concept. Okay, from first case, here you will get one idea in this, you will small doubt in this question, whether do we need to, he asked you to find time, time is equal to distance by speed. Okay, there is no issue with the distance. Speed means whether it is train speed or man speed, you may have a idea, doubt. Okay, so remember here we should take their relative speed. How they are moving? They are moving in opposite direction. Since they are moving in opposite direction, we have to take plus. So you will get 51 plus 3 as 54. I hope you understood everybody this question also. Now we focus on question number 10. Okay. Now we focus on question number 10. Okay. This is something different question. Okay. Question number 10 is something different. Just focus on this question. What the question? A train 120 meter long, blindly train length equal to 120 meter long, travelling at 45 kilometers. So length is 120, travelling with 45 km/h. Overtakes another train. See, observe here. Overtakes another train travelling in same direction. Travelling in same direction at 36 km/h and passes it completely in 80 seconds. In 80 seconds. The length of the second train is, so there are 3-4 interesting points in this question. First one is what? First train length is 120 meters. Okay, first train length is 120. Now we will write what he given, so that you will get the idea. First train length is equals to 120 first train length is equals to 120 meters. And how the first train is moving? First train is moving with 45 kilometer per hour speed. First train is moving 45 kilometer per hour speed. I have to find out the length of the second train. I have to find out the length of the second train. Okay. And second train speed given. Second train speed is equal to how much given? 36 kilometer per hour. So in both the cases, how much time required? 80 seconds. How they are moving? They are moving in same direction. So this is the what you can say basic concept what he given. So with this see, very interestingly again we can find out either you can apply speed equal to distance by time, okay, whatever. Here I am taking distance is equal to speed into time formula. However, you will get the same answer. So distance means one train length is equal to 120, another train length is equals to I assumed x. That is why whether they are moving in same direction or opposite direction, even though one train length is x, another train length is y, if they are moving in same direction or in opposite direction, then train has to cross how many meters? X plus y meters. I repeat, whether they are moving in same direction or they are moving in opposite direction. If one train length is equal to x, another train length is equals to y, then train has to cover how much? X plus y meters. Okay. And it is not about speed, it is about distance. If it is about speed, then relative speed is same direction means minus, opposite direction means we will take it as plus. Okay. Remember this important point. Okay. So now let us start solving this question. 120 plus x, that is equal to speed. How they are moving in same direction? That is why we have to take their relative speed. Relative speed is their minus, that is the 45 minus 36 means 9. 9 is in terms of kilometer per hour. Converting kilometer per hour into meter per second. Time how many seconds? 80 seconds. Solve for x from this equation. So 120x. So here 9 ones are 9 twos are 2 ones are 2 40s are 40 into 2, how much I am getting? 200. From this step x is equals to what we can write here? 80 we can write. So x means what? Length of the another train. What you learned from this question? What you learned from this question is whether two trains are moving in same direction or opposite direction. If it is a distance, you should take plus. If it is speed, if it is same direction, you should take the relative speed, it will be minus. If it is opposite direction, you should take plus. I hope you understood this question also. Okay. Now we focus on one more question, that is question number 11. Okay. Question number 11. So this is also something interesting and different question. Observe here. Telangana Express train travelling at a uniform speed clears a platform of 200 meters long in 10 seconds and passes a telegraph post in 6 seconds. The speed of the train is, okay. One small correction here. So it is not a post, it is telegraph pole. Okay. However, no issue. It is not a post, it is pole, P-O-L-E, telegraph pole, we know already. Okay. I repeat the question once again. Telangana Express train travelling at a uniform speed clears a platform 200 meters. Platform length is how much? 200 meters. Crosses that platform in how many seconds? 10 seconds. And the same train passes a telegraph pole in how many seconds? 6 seconds. See, again there are two cases. In first case there are two cases, that is in first case train is crossing a platform length equal to how much given? platform length is equal to given 200 meters. Okay, platform length 200 meters. Crosses that platform in how many seconds? 20 seconds. The same train again what is doing? The same train is crossing a telegraph pole in how many seconds? 6 seconds. Okay, what he asked to find? The speed of the train is. He asked to find out the speed of the train. Telangana Express train is travelling a uniform speed, clears a platform 200 meters long in 10 seconds and passes a telegraph pole in 6 seconds. The speed of the train is. Okay, no issue. So now we will start doing solution. So train length, platform length is 200 meters. The train is crossing what platform in how many seconds? 20 seconds. And in second case, the same train is crossing what? Same train is crossing what you can say? Same train is crossing a telegraph post in how many seconds? He only given cross a telegraph post in 6 seconds. Okay, chalo. For example, length of the second train is equal to, think that x meters. Length of the second train is equal to, think that x meters. So from this what we write is speed is equal to distance by time. Distance is equal to x. Speed is equal to what you can write? Speed is equal to 6 seconds. Okay. Now in second case what you can find? In second case train is crossing a platform of length is how much? 200 meters in how many seconds? 20 seconds. So again distance is equal to 200 plus x. Distance equal to speed into time. Speed how much there? Speed we have to find here. Speed we don't know, right? And the same train, right? Since it is same train, we can find out x by 6. Speed into time. Time is only given how much given? 20 seconds. I repeat the question once again. In first case train length is 200 meters. In second case train is what? Platform length is 200 meters. The train is crossing a platform in 20 seconds. Again same train is crossing a telephone pole in how many seconds? 6 seconds. So from this case we can find out the speed. I am using same speed here. Distance equal to speed into time. Simplification. 2 𝗑𝗏 or else see it won't go in second table. Okay, that's why what we will write here? We will write here x by 6. So 2 𝗑𝗏 2 𝗫𝗏. Simplification. 600 plus 3x is equal to 10x. Okay, from this 7x is equal to 600. X is equal to 600 by 7. 600 by 7 is what? If you simplify this, you will get the length of the second train. Okay, but what he asked you to find? If you observe here, he don't want length of the train. What he asked you to find? He asked you to find out the speed of the train, right? So since he asked you to find out the speed of the train, substituting this x value here. So if I am substituting that x value here, what I am getting? 600 by 7, okay, by 6. So 100 by 7. Simplification, you will get the answer either in terms of meter per second. If he asks you to find in terms of meter per second, or kilometer per hour or kilometer per hour. Okay, I repeat this question once again. First case, train length is equal to I don't know, I assumed x meters. Train is crossing a telegraph post in how many seconds? 6 seconds. So distance is there, time is there, I am finding the speed of the train. Again same train is doing? It is crossing a platform of length what? 200 meters in how many seconds? 20 seconds. Okay, that is why distance equal to this. I am using this speed here, speed into time. X value something I am getting 600/7, substituting x value here, so I am getting 100/7 meter per second. Or if it is in terms of decimal points, you can find in terms of decimal points, that is no issue. Okay, so this is one question. Okay, so there are see, now we will focus on one more question, final question from this chapter. Okay, still many are there. Okay, but you need to focus on this once again. See, observe question here. The length of the train and that of a platform are equal. See, something different. The length of the train and the length of a platform are equal if with the speed of 90 km/h the train crosses a platform in 1 minute, then length of the train is. Okay, here length of the train and platform are equal. The length of the train and the platform are equal if with the speed of 90 km/h the train crosses a platform in 1 minute, then the length of the train is. So here we can able to solve here itself, we can solve here itself. Okay, since train length and platform length are equal, if I assume train length is equal to x, then platform length is also x. So total length travelled by that train equal to how much here, 2x we can take. Okay, so distance is equal to speed into time formula, distance is equal to speed you only given how much, 90. Since it is in terms of km/h, converting into meter per second. In how many minutes? 1 minute. So since it is 1 minute, we have to convert into seconds. So simplification. Okay, it is very easy. 6 10s, 6 3s, 3 30s. So here what I am getting, I repeat, 6 10s 60, 6 3s 18, 3 1s 3 30s. So 2x is equal to what I am getting, see, 300, 1500. So x is equal to 1500 by 2 means what I can write here, 1500 by 2 means 750 meters we can take. Okay, these are the, I hope you understood this also. Okay, these are the different models, different concepts. Still some models are there. Okay, candidate has to focus on that. Okay, so whatever, focus on the basic concepts. Okay, then you need to focus on what I can say, conversion of units, whether train is crossed a platform or train is crossed a tree, you need to focus on this, then you can able to solve any kind of questions. Okay, thank you very much.